Hello, Petra. I'm audible. Petra, is it audible or not? Please let me know first.
Yes, sir.
All right. So, okay. In the last class, I gave you some of the relation like I is equals to N, A N E V D. VD was equals to E tau by M on the negative. So you can simply say that the magnitude will be written as E tau by M. With this tau is nothing but uh, time delay between two successive collisions. This is one thing. Okay, that is the thing, okay, which we did yesterday. That is fine for now. If I ask you, Kirtana, what is the current density? So you can simply say that current density is nothing but I by A, basically whatever the area divided by this. And we have got this relation, so you can simply say ANEVD divided by A. So you can simply say that the current density is also equals to NEVD. This is basically, you can see a relation between current density and this. Okay. It's better if you could remember the formula of VD as this by this. This is more useful, right? The density divided by the number density into this. All right.
Yes, sir.
Okay. So I'm just giving you one problem. Try to solve it. A current of 16 ampere is passed through a conductor in constant in which concentration of electrons 4 into 10 to the power 28 meter per minus cube. Okay. Basically, this is the volume, like concentration of electron. Its area is cross section area. Cross section area. What you can take is some good value. We can take that 2 this is 25. So it's, yeah, 25 meters square. Find the velocity of electrons in the conductor. In conductor. Okay, this is the problem. Just solve it and let me know the answer. This problem is based on whatever we have discussed till now. Like you can say that this part is enough to solve this one. So yeah, you can just try this and let me know the answer. The time I can give you that is 5 minutes somewhere now. Okay, solve it.
Sir, is it 4 into 10 to the power 23?
Kirtana, how much you are getting?
4 into 10 to the power 23, sir.
4 into 10 to the power 22. No, Kirtana, that's not the answer. I think thinking simply just go with us. Like, and think find the velocity of electrons in the conductor. What is that? You can simply say that is VD, right? Drift velocity. Because at the end of the day, whenever you are having some current and something, velocity of electron is nothing but a drift velocity. So what is the formula? You can either use this by m, or you can use another one, that is J by m. So just look at the data which is given. So you can simply say that the current is given. There's no relation over here. What is the next? These things are given, but you don't have any relation out of these, right? Then you see this. But what is the relation? Do you have this J? Yes, I can see it because this J is nothing but I by area, right? So this can be right. Now you can simply say that I is given as 16, area is given as this much, 10 to the power minus 5. This is nothing but number density. Okay, what is the total number of electron divided by this? Alright, so isn't it what? What is the concentration? Something divided by the volume. So we are given to this thing also is 10 to the power 28. What is the electron? Charge on the electron is nothing but 0.6 into 10 to the power minus 19. So if you solve it out, you are supposed to get something around 2.5 into 10 to the power minus 4 meter per second. Okay. You can simply say that from here you are going to get 4. From here, if you solve it, something around 2.5 you are going to get. This is 28, this is 8, so will result to 10 to the minus 36. This is 19, this is result to negative 19, something minus. Yeah, it was positive. So when you do with this and this, the 8 will remove it, you will be getting just 20. So in the positive, this is something around minus 19. Okay. It's almost. Okay, sorry, sorry. This is given as 5, right? So you have 8 is 5. This will be 5, so this will result to 22. So you can, when you solve it, you are going to get something around 4. And when it goes to the top, it will become this. This is the solution for you. Okay. Any doubt? Any query?
No, sir.
Is it clear?
Yes, sir.
Okay. Mm, okay. Let's move to the next. There's another problem here. We can solve it before moving to the next. Just a second. Ketan, just try to solve this one and let me know the answer, okay? Ketan, have you solved it or not? Or are you solving it right now?
Solving, sir.
Kirtana, you're done with this problem or still doing? Or should I solve the problem? Hello, Kirtana, is it
Doing so.
okay? Doing. Try this one. Yeah, Kirtana, hello. I'll just give you the solution for this one. Then we will move to the next problem. Okay. I hope it will work. So look, the problem says you are given a square cross section of 6 mm. So you can simply say that you are given something like this. Okay. A square cross section. 6 mm is the side, so you can simply say this is 6 mm. This is 6 mm. So if I just ask you what is the area, cross section mean to say there is a copper wire, a long copper wire, whose opening is instead of being a circle, it is a square kind of. Okay? This is a kind of opening given to you. So you can simply say the area for this one is 6 into 6. Okay, this is mm square. You have to remember the unit. This is the important thing. Okay, now what you have to calculate, find the current density in the wire. So current density has multiple formulas. You can simply say NEVD, okay, or I by A. Let's see what is given to me. So I have given a wire length, okay. Current is also given, so I might be using this. Free electron density in the conductor is this much. So basically this is also given electron density. This is nothing but how many electrons are present there and time taken. Okay. So basically it is asking two things. So first I'll be calculating this part, how I can say that current divided this. Current is this much. What is the area? You can simply say 636 mm square. Mm square, you can, if you convert it over there, what you are going to get it as, if you convert it into that things, meter, so it will become this 10 to the power minus 6. So just solve it and you are going to get 10 to the power 5. This is your current density will look like. The next is time taken for an electron to travel in the length of wire. So again, a very simple idea. This is the length of wire 10 meter. Assume an electron is there. So how much time it will take? You can simply say that distance divided by time gives you velocity. So this velocity is nothing but, like, time is nothing but whatever the distance divided by Vd. So you can say distance given is 10. What is Vd? This is drift velocity. How I can calculate drift velocity? One formula is J by Ne. If you use this, I hope you can solve it. So you already know the value of J, that is 10 to the power 5 divided by N. N is given as this much, 8.5 into 10 to the power, what is that? I think 28. Okay, into 1.6 into 10 to the power minus 19. Okay. This can result you the what is that, VD. So I am interested in getting this time. So I'll just write this and divide it. So when you do this, 16, I think this is 10. So this will be 10 divided by VD. VD goes to upside. So whatever in the denominator will go to numerator. 8.5 into 10 to the power 28 into 6, 1.6 into 10 to the power minus 19 divided by, yeah, it will be 10 to the power 5, I think. So just solve this one and somewhere around, I'm not sure, but something around 1.3 5 into 10 to the power. What are the powers? So this is 28, 19, so it comes out as what is that? 8 and 1, 10. Now this will be like 9 as a power. Below is this 5, so it will result to 4. How much is that? 5. So this multiplied by this again a big parameter. So yeah, this will result to something around 10 to the power 6. Okay. Second, this is the answer. Let me know if you're clear with this thing.
Yes.
Kirtana, clear, right? Can I move to the next problem?
Yes, sir.
Okay, I'll be sharing another problem. So look, before that, maybe we can just go through one more concept, that is mobility about. Or let's not go with the mobility maybe. I, I can go with the mobility and the concept. Yeah, one more concept is there, that is mobility. Mobility is nothing but how active your electron is. So I can simply say that it is nothing but drift velocity per unit charge, per unit electric field, drift velocity per unit electric field. A small formula is there, okay? Electric field. So this is representation of mobility. Mobility, like how mobile your electron is. Vd divided by electrical. This is the value of mobility. Okay, formula. So one problem I'm giving you on the basis of this itself. Maybe you need to know the concept. So that's why I was. So just try this problem. Get me the answer first. Concepts are already discussed, whatever is used in this problem. So you just have to get me the answer for this. Okay. Kirtana, have you solved it? Hello, Kirtana, have you solved this one?
No, sir.
You're trying?
Yes, sir.
Which way you are trying? Just let me know the way, method which you are following to solve it. Okay, look, Kirtana, just look at the solution for this one. Given a conductor of length this one, maybe something like
Mm.
this. Okay, 40 centimeter, this and this. Potential difference across it is something you can say this is a one terminal, this is another terminal. So potential difference across this is nothing but 100 volt basically. Between find the mobility of the electron. Mobility of electron is nothing but okay, mu is equals to Vd divided by electric field. So you are given this and electric field you have to calculate. What is the electric field? If you know that this is a conductor, the electric potential difference is V. Okay, so you can simply say there must be some electric field. What is the electric field? That is nothing but V divided, like voltage divided by the distance. Okay, that is what is the voltage? 10 volt divided by distance 40 centimeters. So 40 into 10 to the power minus 2 just to convert centimeter into meter. So this results to 100,000 divided by 40 gets 125. Electric field is 25 Newton per coulomb. Okay. Mu is nothing but 5 into 10 to the power minus 6. What is that electric field? This goes to 5. Something around it will result to 2 into 10 to the power minus 7. This is the result. If clear, just let me know, or else I can solve it next.
Yes, sir.
It's clear, right? Okay. Kirtana, do we had a discussion about the Ohm's law?
Yes, sir.
Okay, so I think all the concepts are clear with respect to that, right?
Yes, sir.
Okay. Okay, so Kirtana, what happens is generally let's come up to the circuit solving part. A small discussion I'll just have. So basically, a resistance is shown by this. Okay. Whenever I'm writing like this, let's say this is A terminal, this is B terminal. So assume there's a current flowing. Okay. I'm saying this current is I. So what is that? This means that this is a resistance R. So how you can write that? V is equals to IR is the formula. What is this? V is the potential difference across. What is the potential difference across it? You can simply say, sir, there's a potential V and I. You all you know that current goes from higher potential to lower potential. That if direction is this, you can simply say that this is higher potential, lower potential. So what is this? You can simply say VA minus VB is equals to this current I times of what is the R. So this I will become VA minus V times of V divided by. Okay, this is one thing. Okay, now I can have a small discussion. Okay, let's end up Kirtana here because in the next class I'll be discussing another topic, that is effect of temperature on resistivity. A small just introduction I'll give you. The resistivity is nothing but m by n e square tau. This is the formula of resistivity if you could remember. M by n e square tau. So yeah, this is a number density, or another name is concentration of electrons. Of electrons. Okay. Electron, and this is what is it again? Tau. Mass of electron. That's it. These things are there for today's discussion. Any doubt, please let me know. Three problems we have solved. A small list overview I gave you earlier. Three problems, and this is small class discussion. Okay. Next class, huge discussion will be there on this topic, followed by some problem practice, and I can say we are done with this chapter. Although a lot of things are there, a lot of problem solving part are there. So
Yeah, still it will take some time to complete, but yeah. So yeah, that's all for the today's lecture. You can leave if you don't have any kind of doubt.